Hello class, this is going to be the geometry midterm review. Um, I know I posted in the Google Classroom I use the textbook pages, but probably that'd be more useful to do in class, where I can answer particular questions, like answer like questions you might ask me. So instead, what I'm going to do is do the old test packet that I handed out. If you still need a test packet, you can email me or ask me in class. I have a couple extra copies, so I don't feel comfortable posting my test packet online because it's a very easy way to just like copy it and you give it to your next year's people. So I just rather just I give you a physical copy. I don't mind that, but online it won't allow to post it, or I don't want to post it. So instead, I'm just going to do the tests from 1 through 7, chapter 1 to chapter 7, and hopefully that's a good help for you guys and a good starting point. So, okay. All right. So this one, the section chapter 1, a lot of it is terms and knowing terms. So maybe for you guys, maybe you want to make a Quizlet, I don't know. But there's a lot of terms like collinear, coplanar. So collinear means they have to share the same line. So does E and F and E share the same line? Well, FE is on the same line, so I would say yes. So this is a true. Okay. Is points F, B, and C coplanar? So that means they're on the same plane. So F, B, and C. Definitely, you could clearly see that F is above the plane, kind of like sticking out on that line. So I'm going to say that one's false or, excuse me, or false or no. False. Over here, line CE lies on plane A. So line CE, so this line, lays, so lies, like on the plane A. So this is plane A. It does seem like it lies on it, so I'm going to say yes, true. Line FE intersects with line CD. FE intersects with CD. Intersects means that they hit each other at a certain point. In this case, they hit at point E, so yes, they do. That is true. Name 3 rays in the figure. So a ray is a point to a ongoing line. So I can say EC is a ray, EF is a ray, ED is a ray. Is there any other rays? Not that I see particularly, but those are the 3 rays I would point out to. Number 6, name an intersection between plane A and FE. So kind of the same thing back here where we had point E is the intersection between the lines. That means that plane A, which is this flat 2D space over here, is getting like pierced or touching the line F E at point E. So in this case, the answer here is point E. I just want to take the second. Points are zero-dimensional. Lines are one-dimensional. So a line is one-dimensional, it only has length. Planes are two-dimensional. So for example, it has a height and a width, or a height and a length. And then you have like cubes are three-dimensional. We didn't do much with 3 dimensions yet. That's near the end of the year for finals, in your final time. But this is good to know. Find the distance and midpoint of points 6, 4 and 1, 8. Okay, so do 2 different things. First, let's do distance. In order to do distance, we need to know the distance formula. So the distance formula, and this distance formula should look familiar. This is actually a difference with, this is slightly different from Pythagorean theorem, or I should say it's the same thing, just written differently. So I just want to write this so you can see the connection. So a squared plus b squared equals c squared. Okay, so the distance formula is the square root of x1, this is minus, yeah, minus x2, plus, and this is squared, plus y1 minus y2, which is squared. I believe that is correct. Let me just check. Yeah, that's definitely correct. Uh, Sometimes the equation, if you look online or look in your book, I think it might say x2 minus x1 and y2 minus y1. It doesn't really matter which y is first or second. What really matters is more so that you keep it consistent. This midpoint formula, what is it this way? Yeah, so some equations do x2 minus x1. It doesn't really matter, as long as it keeps consistent. So I'm going to call this group 1, okay? And I'm going to call this group 2. And this is my x, this is my y, this is my x, and this is my y. So now I'm going to plug it into this bit here. So the square root of the distance between the two x's, okay, the distance between two x, you could say is a squared, which is 6 minus 1, plus the distance between y1 and y2, so that's negative 4 and 8, squared. So you could say, look at this thing. This thing is the distance or the length of side A, and this is the distance or the length of side B. So there's some connections you can make with the Pythagorean theorem and the distance formula. They're the two sides of the same coin. So 6 minus 1 is 5. 5 squared is 25. And then negative 4 minus 8 is negative 12. Negative 12 squared is going to be 144. Remember that when you square a negative number, it still goes positive, because a negative times a negative is a positive. And then we're going to add these up. So 25 plus 144 is the square root of 169. The square root of 169 is a very clean number, 13. So the distance between these 2 points are 13. Okay, so midpoint formula is kind of similar. You just take the average between the 2 points. So the average between x's is x1 plus x2 over 2, because you add two things and you divide it by how many numbers you added by, which was 2. And then the y should be y1 plus y2 over 2. So you add the two things and then you find the distance in between. So here's 6 plus 1, 6 plus 1 over 2, comma. And then this is going to be negative 4 plus 8 over 2. 6 plus 1 is 7, 7 over 2. I could leave it at 7 over 2. I could also be in 3.5. It's a multiple choice, so it could be either one, but you know how to tell the difference between that. Negative 4 plus 8 is 4. 4 over 2 is 2, and that will always be 2. So either one of these answers you should expect for as a possible multiple choice option. Okay? Either one of these answers you expect for a multiple choice option. Let's go on to the next one. Naming angles and using different type of angles. So there's a couple of type of angles. Acute, that's less than 90. There's right, that's exactly 90. Let's just say equals 90. And then there's obtuse, which is a greater than 90. And then there's a straight angle. We don't really talk about this one, but this one is exactly 180. Okay? So let's see what we could do. What type of angle is BGE? Let me just zoom this out so you can see the actual thing. Again, this is the test packets. So BGE, and it's really tiny here, so BGE is 50 plus this number here, and you can't really see it from the angle, but this is 70, this is 50, this is 40, or 50 and this is 40. And we know the whole thing's a straight line, so we know it's 180. So I could find this missing angle by doing 180 minus 70, minus 70 plus 50 plus 40. And that's going to give me 20. So I know this one's 20 degrees. Okay, so I need to add up all the missing angles. So 50 plus 20 plus 70. It asks what type of angle is. So the measurement is actually 140, which is an obtuse angle. Okay. And next is what's the measurement of angle AGD? So let's see, angle A, and I'll put it in a box, GD. So this is 40 plus 50. This is 40 plus 50 plus 20. So that's going to be around around 40 plus 50 plus 20 is going to be 110. So the measurement of AGD is 110 degrees. What's the measurement angle AGC? So AGC, which is this one up here. So AGC, you can kind of see it from the picture, but 40 plus 50, you never should assume from the picture. You should assume with the information you got. So 40 plus 50 equals 90. Name a pair of adjacent angles. So a pair of adjacent angles are two angles that share a middle line. So I can name this pair adjacent angles. So this one is adjacent to this one. So I'm going to use that as my example. So A, G, B, and angle, I should say angle, and angle B, G, C. So those are my two angles that are adjacent to each other. All right. Given that M is the midpoint of CG, find the length of CG. So the midpoint is always what's in the middle, which means the two pieces are the same. So if I know this is 4x minus 5 and I know this is 2x plus 7, I can set them equal to each other. 4x minus 5 equals 2x plus 7. Let's see, subtract 2x plus 5 plus 5 plus 5, subtract 2x. I have 2x equals 12. Divided by 2, x equals 6. That's good. Okay, given that ABD, so x equals 6 for this one. Oh, and then it asks you for find the length of CG, so we got to be careful with that. So find the length of CG, so we got to plug it back in. So I'm going to find this one, I'm going to plug 6 here. So 6 times 4 minus 5, 6 times 4 is 24, 24 minus 5 is 19. So this is 19. I don't have to plug in 60 here. I already know if this side is 19, this should also be 19. So since they're both 19, I know the whole line is 38. So your final answer is answer 38. On the multiple choice, make sure to fully read the question, because I might just put 6 and you think, oh, I got x equals 6, that must be the answer. Since I'm asking for CG, you have to put in CG. Here we go, next one, angle ABD, so this big line, is a straight angle, which means there's 180 degrees. So let's find angle CBD. So first, let's find what x is. So since I know this is a straight angle, what we call supplementary, we're going to do 2x plus 9 plus 10x plus 15 equals 180. Okay, let's combine like terms on the left. So we have 12x plus, this is 24. 24 equals 180 minus 24 minus 24. 12x equals 156, and then divided by 12, x equals 13. So x equals 13 is my answer? Well, no, they're asking me to find CBD. So to find CBD, I got to plug in x equals 13. So that is going to be, 13 is going to go into the equation. I'm looking for CBD. So CBD is this one. So I'm going to plug it in here. 10 times 13 plus 15. That's 130 plus 15. That's 145. So your answer is actually 145, not 13. Make sure you read the question fully on the tests. Okay, let's go to the next one. All right. X, Y, Z, and LMN are complementary. Solve for X. So if I know they're complementary, that means one thing. That means they add up to 90 degrees. So I can set these two equations, 2x plus 6 plus 5x plus 21, and set it up to 90. So that's 7x plus 27 equals 90. Subtract 27 on both sides. That's 7x equals 90, 80, 70, 63. Divided by 7 on both sides. That's x equals 9. Since it's solved for x, we got x equals 9. We're happy. Given that angle 1 is a supplement of angle 2, and angle 1 is 32 degrees, what's angle 2? So this question is even easier than the previous one. So you know they're supplementary, so that means it's 180 degrees. So then if I know this is 32 degrees, And I know the whole thing's 180. I just got to find what angle 2 is, which I'll call x. So I just subtract 32 on both sides. Don't worry, you better believe on the multiple choice question, I put what happens when you do 90 minus 32. Like I'm going to put option 58. So make sure you read clearly that it's supplementary and not complementary, because I will be putting the fake answer down. So that'll be 148. Yep, 148. And there's my answer. 1 is a complement. Complement's 90 degrees. Of 2, if 1 is 56, 90 minus 56, that's going to give me 60, 30, 34. So my answer is 34 degrees. This one, BD is an angle bisector. So angle bisector is kind of like the midpoint. You know that you're cutting the angle in half. Since you're cutting the angle in half, you know the two halves have to be equal to each other. So to find the angle ABC, so the whole thing, we're going to plug it, we're going to try to solve for x first. So that's 2x plus 24 equals 3x minus 12. Subtract 2x plus 12, x equals 36. Now I'm going to plug 36 into one of these. Remember, since I know they're bisectors, I know they're going to be equal to each other. So I don't really have to plug into both of them. I just plug it in one of them and repeat. So 36 times 2 is 72. 72 plus 24 is 96. So 96 here, and this is 96 here. 96 plus 96 is 192. So your final answer should be 192. That's the measurement of angle ABC, this whole wide angle. Okay. Let's keep going. And I have to actually clarify. When I say this angle, I do not mean the bottom angle. I would mean the top angle. Okay. Okay. The lengths of two sides of a regular hexagon is 5x plus 10 and 6x plus 2. It's okay if you don't remember what an actual hexagon is, because the key word is not hexagon. The key word is that it is a regular hexagon. So because it's a regular hexagon, you know that each side is equal to each other. So this is simply 5x plus 10 equals 6x plus 2 minus 5x plus minus 2 on both sides, 8 equals x. If you set them equal, 8 equals x. It says find the length of each side of the hexagon, so now I need to find the length of this. So 5 times 8 plus 10. 5 times 8 is 40. 40 plus 10 is 50. If you plug it into 6x plus 2, you should get the same answers. 8 times 6 is 48. 48 plus 2 is 50. Okay, equiangular triangle. So equiangular means all the sides are, or all the angles are equal. For a triangle, that also means all the sides are equal. But since we're talking about angles and it's equiangular, that's all I need to know. So these two are equal to each other, so 7x minus 3 equals 4x plus 24. I'm looking back at this test, man. I gave some easy numbers. You guys should be grateful. So minus 4x minus 4x, 3x plus 3, that's 27. X equals 9. So x equals 9. Okay. I think the camera froze, so I'm just going to go over one this time. You set them equal to each other, then you solve. So you got x equals 9. All right, always, sometimes never. Some people dread it. It's okay. We could get through it. So, first off, a quadrilateral is convex. Ooh, what does convex mean? Convex means that all the angles point outwards. There's no inside angle like this would be an inside angle. It kind of points inside to the shape. So a quadrilateral is convex. Well, I just draw a four-sided shape here that's convex. And let me see, I could draw a four-sided shape. Quadrilateral, oh, I should make sure that you know this. Quadrilateral is a four-sided shape. So I just made a quadrilateral where the angle goes inside the shape. So that is not convex. That's a concave. So because of that, it's sometimes true. I showed an example of when it could be and when it could not be. So that's sometimes. A regular polygon is equiangular. So a regular polygon is equiangular. So a regular polygon, regular implies in the definition that all the sides and all the angles match. So a regular polygon be equiangular, and equiangular means all the angles match. By definition, you know a regular polygon is matching angles. So this is always true. A triangle's concave. So you try to make a three-sided shape. Triangles are three-sided shapes. Can you make any way that they go inside each other? There's no real way to make it inside each other. You remember all the angles add up to 180? And there's a reason for that. You can't make it go into each other. You can make it with a four-sided shape back here, but not with three. So since you can never make it concave, this would be a never. A polygon that is equiangular is also equilateral. Now, equiangular means all the angles are the same, while equilateral means all the sides are the same. So is that always true? Well, a polygon that's equiangular is also equilateral. That implies that all the sides are equal. All the angles are equal means all the sides are equal. So if you look at here, I just drew a rectangle. We know a rectangle, all the angles are 90 degrees, so it's equiangular. But we also know in a rectangle that these sides are equal to each other and these sides are equal to each other. They're not equal to each other. They're not all four equal. Like they're equal to the opposite sides, but they're not all four equal. Because of that, you have an equal angular situation without equilateral. You could also draw a square, which is both equiangular, equiangular, or a triangle that's equiangular, equiangular. So there's sometimes it is, sometimes it's not. All right. Any line, segment, or ray that cuts a segment into two pieces is called a bisector. Now, bisector is a very particular definition. Bisector means it cuts it in half. So because a line or ray or a segment that cuts something in some pieces doesn't necessarily mean it's going to cut it in half. So I can make a line here and I put my line over here. This is definitely not in half. Well, I can put it over here, which is half. So sometimes. Sometimes it is a bisector, sometimes it's not. Okay? Always situation would be is I said I would say a segment line that it cuts into a segment into two pieces intersects it. Then yeah, you could say it like that because it got cut into two pieces. That would be always situation. The distance from a midpoint to the end point is the same both ways. So what does that mean? So a midpoint is the point in the middle of the line. So this distance here should be the same as this distance here. That makes sense because if it's in the middle, it's the same distance from the one side to the other side. If you're in the middle of two doors, you're going to go the same distance here to here. So that's always true. That's in the definition. Always true. Okay, so hopefully that helps you out with the always, sometimes, nevers. Oh, this is interesting. I guess I had a bonus question in this one. Draw a heptagon, so a seven-sided, that's equilateral but not equiangular. So seven-sided shape, if there's all the same sides, I could kind of draw it like this. And then that's 1, 2, 3, 4, 5, 6, 7. Like there's a heptagon that's equilateral but not equiangular. So that means that 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7. So seven-sided shape, all the sides are equal, but not all the angles are equal. Because this angle is like some big thing. This is smaller, this is an obtuse angle, clearly. This is some other angle. Okay. Oh, chapter test 2. So this is just this was the beginning of our proofs, everyone's favorite, and everyone's second favorite, always, sometimes, never. So let's do it. Through any 3 points exists only one line. So let's see. Through this point exists only one line. That's good. But points like this, there's not one line that hits all 3. There's 3 different lines I could draw, but there's not one line that hits all 3. So through any 3 points is exactly one line. Is it exactly one line? No. Sometimes when it's lined up, but not most of the times. So because there's one case, this is more of an exception than this is. Because the chances of 3 random, like imagine if you threw 3 rocks on the ground, what's the chances that they will land in a straight line? Typically, not often. So because of that, we're going to call that a sometimes. But it could happen. So that's a sometimes. 2 points, if 2 points line, if a 2-point line is in a plane, the line containing them also lies in the plane. I guess this should be lies. I imagine that's what I meant here. So if 2 points lies in a plane, then the line containing them lies in the plane also. Okay, so you have a plane here, and we said the 2 points are actually on the piece of paper or on the plane. So the line that contains the 2 points have to also be in the plane, even if it extends through it. Remember, planes are actually infinitesimal, as in they go on forever. So even though I don't draw the rectangle to cover up the whole page, what you need to know is that even though I don't draw the plane to cover up the whole page, the plane is actually going on forever. And because of that, the line, it goes on forever. So they also go on forever, so it will always be on it. So this is always. A line and a plane intersects. My phone is freezing a lot, and I apologize for that. A line and a plane intersects. Intersect at a line. So a line and a plane intersects at a line. So you have your plane right here, and you have a line that goes through it. Let's say this point, and then we have like a dotted line to indicate it's behind it. It doesn't intersect at a line. It actually only intersects at one place, at a point. But here's the thing. I could also draw it as a line laying on top of the plane. And if it lays on top of it, then the intersection is all the line. So is the intersection a line? Yes, it is. So sometimes it is, because they can lie on top of each other. If two angles are complementary to a third angle, then the first two angles are congruent. So what does that mean? If two angles are complementary to a third angle, so this angle, and let's call it this angle, is both complementary to this angle, then these two angles have to be the same. Well, let's think of it like this. If we said this angle is, let's say, 50 degrees, right? So we know 50 degrees plus angle A equals 90. And 50 degrees plus angle B equals 90. Does that make A and B equal? Well, if I subtract 50 on both sides, I will get A and B equals 40. No, I'm sorry. A equals 40. B equals 40. So if A and B equals 40, I can use the transitive property because the middleman's 40. A equals B. So yeah, that's always true. That will always, always be true. So that is always. And I think there's a name for the theory, but it escapes me right now. If two angles form a linear pair, they are complementary. Well, two angles that form a linear pair means that the line itself is 180 degrees. Complementary means 90 degrees. By definition, they're not compatible, so that's never. That never happens. All right, let's state these postulates. So there's a couple of postulates. If you could remember, one is reflexive, one is transitive, one is substitution. We also have like the algebraic postulates, like adding, subtracting, multiplying. So, for example, we're going to do JK equals QP, and QP equals ST, so JK is ST. Since you have a middleman here, this is called the transitive property. Because QP is the transit, or like the bus that connects me between JK and ST. Transitive. I don't know how to spell. Transitive property. If JK equals HI, HI equals JK. That is a reflexive property. Actually, let me flip over because I might have just used that incorrectly. I think that we have something else called the symmetrical property. And I don't want to be called a liar on my own YouTube video, so let's check that real quick. Chapter 2, postulates and diagrams, using reasons. Oh, I apologize. That's not reflexive. Reflexive means exactly the same. This is going to be symmetric. See? Even I can make mistakes. And you know that already. So symmetric property. That's a symmetric property. If AB plus CD equals EF and CD, that must mean AB equals EF. So what that means is that since I could add CD to both sides, that means I could use the additive property. Or actually, I'm sorry, since I have this and then equals this, what would I do? This would be a subtractive property because I could subtract CD on both sides and it would be equal to each other. So this would be the subtraction property. Our next one should be reflexive. So AB equals AB. Well, AB equals AB. That is reflexive. Now I know that for sure because I checked it up in, that was section 2.5, if you ever want to check it, 2.5 in your textbook. If some reason you got it in your notes. If 10x equals 2000, that x equals 2000. What did I do to both sides? I divided, so that's the division property. Okay. Let's go to the next. And remember, since it's multiple choice, it might just say the property, so you just have to figure out which one it should match with. You don't have to necessarily, oh, you should know the properties because we got to do some proofs. W equals Z. So if I know W is congruent to Z, then I know these two. 11x minus 8 equals 9x plus 4. Plus 8 minus 9x, that's 2x equals 12. X equals 6. Over here on the right, now what we know about vertical angles is that this should equal this and this equals this. So if I want to find both x and y for this, I'm going to find y plus 20 equals 70. Vertical angles equal each other. I also know that this one is going to be 2x plus 40 equals 110. And so to find y, I subtract 20 on both sides, y equals 50 here. And then for x, I subtract 40 on both sides, so that's 2x equals 70, divided by 2, x equals 35. Over here, vertical angles, this square means a right angle, so I know that 90 equals x plus 38. Subtract 38 on both sides, x equals 9, 8, 7, 6, 52. Okay, here, this one's easier than the top one. Vertical angles is this one and these. So y is really easy. Y just equals 168. Now, I could do this and do x equals 5x minus 48. What I could also do is see that this is a linear pair. And since this is a linear pair, I know also 168 plus x is going to equal 180. Both are going to yield the same results. So this one, just subtract 168 on both sides, that's going to be x equals 12. Over here, I would subtract 5x on both sides, so negative 4x equals negative 48, divided by negative 4, divided by negative 4. So that would be x equals 12. So two ways to get the same answer. Here, y equals 168. That's the easiest way to get that one for sure. Okay. Let's continue. Ooh, algebraic proofs. All right, so we got to prove this. So first, let's always start with the given. Nothing wrong with starting with the given. That's given. Then I'm going to distributive property equals 5x minus 8. So that's distributive. Then I'm going to, let's see what I could do. I'm going to subtract 3x on both sides. So that's 6 equals 2x minus 8. That's subtraction property. Then I'm going to do plus 8 on both sides. 14 equals 2x, additive. And then divide 2 on both sides. So 7 equals x. That's the division property. Division property. There's multiple routes to get to the same answer. As long as your reasons matches what you're doing, that's what matters the most. Okay, let's get to the next one. Okay, so you have a proof here that you have to fill in the blanks. So let's do that. 3 and 2 are complementary. Hey, look at that. That's given. 1 and 2 equals 90 degrees. 1 and 2 equals 90 degrees. Hey, look at that. That's given. 3 and 2 equals 90 degrees. How do I know that 3 and 2 are 90 degrees? Well, I know 3 and 2 are complementary. So since I know 3 and 2 is complementary, by the definition of complementary angles, I know that they add up to 90 degrees. Just want to make sure, yeah. So definition of complementary angles. I know they add up to 90 degrees. Okay. So since this equals 90 and this equals 90, I can set these two guys equal to 90 with the transitive property. And since these two, and then you have M2 and M2 here, so what could I do to get rid of these? Then that means I could subtract. So that's a subtractive property. And then the measurement of two equal angles means that the two angles are congruent. So that is the definition of congruent angles. So because the measurement is equal to the two angles, that's the definition of congruent angles. Okay, just leave that up there. Let's go to the next proof. I think there's a completely clear one. Let's see this one. Prove the right angle congruence theorem. Okay, so if you don't remember, the right angle congruence theorem was that two right angles always equal each other. So the right angle congruence theorem, that is that two right angles always equal to each other. And I just want to look in the book to see how they did it, because I don't want to make a mistake on the YouTube video. Not any more mistakes than I'm already doing. So let's check. Prove statements about segments and angles. It's vertical angles. I want the right angle. Okay. All right. So I do remember it correctly. All right. So let's start off with what we're given. Angle 1 and angle 2 are right angles. Well, look at that. We know that because it was given to us. Real easy there. Second part. Since we know they're right angles, then we know the measurement of angle 1 equals 90 degrees. And I could put this in the same line. The measurement of angle 2 equals 90 degrees. And I know that they're 90 degrees because the right angle means they're 90 degrees. So that's the definition of right angles. By definition, right angles are 90 degrees. So that's why I know it's 90 degrees. Now, since 90 and 90 are equal to each other, I could just set up that measurement of angle 1 is equal to measurement of angle 2. Because these two are equal to each other, that is a transitive property. Now, if we have the measurement of angle 1 and the measurement of angle 2, we could change that into the angle 1 being congruent to angle 2, because that's what we were looking for. I'm not looking for the measurement of the angle. I want to know if these two angles are congruent. And I know these two angles are congruent because the definition of congruent angles tells me that when the measurements are the same, the two angles are the same. At this point, I'm done. I got to the prove over here, which I'm very happy with. I believe that's the end of chapter 2. So let's get right to chapter 3. Okay. And we're going to start with the dreaded always, sometimes, never. Let's see. If two lines are not intersecting, then they're skewed. Okay, so if two lines are not intersecting, so let's first remember what skewed is. Skewed is when they're kind of dodging each other in three-dimensional space. So I'm going to draw myself a rectangular prism to illustrate this. So this line here, let's say AB in the background, and this line here in the foreground, let's call it CD. So CD is in the foreground, so it's kind of like in the front, while AB is in the background, in the back, going like this up and down. These two lines will never hit, not because they're parallel, but because they're on two different levels, like two different 3D dimensional planes. So because of that, they are skewed, and they will not hit each other. That is true. But look at here. If two lines are not intersecting, then they're skewed. Sometimes they're not skewed. Sometimes they run right next to each other, like a pair of train tracks. Now, a pair of train tracks are on the same ground of Earth, so they're on the same plane. So this is called parallel. So sometimes, the answer here is sometimes, when the lines don't hit each other, they're skewed. But sometimes they're also parallel. Consecutive angles are congruent. Consecutive angles are congruent. So what is a consecutive angle? So a consecutive angle, and I just want to make sure I get the correct definition. I must have met consecutive interior angles. So let me do that. Consecutive interior angles are congruent. So if consecutive interior angles are congruent, now if you don't remember what consecutive interior is, it's the transversal thing. What is a transversal? Well, it's that one line that crosses into the two other lines. So consecutive interior means they're on the same side of the transversal and they're on the inside. So are two consecutive interior angles congruent? Usually not. Usually they're supplementary. But there's one situation where they can be congruent, and that's when they form parallel or perpendicular lines, so that they end up being both 90 degrees. So sometimes they are, and sometimes they're not. I'm sorry, sometimes they're not, and sometimes they are. So the answer to this one is sometimes. Okay, next one. If there is a right angle, then the two lines forming the angle are perpendicular. So if there is a right angle, then the two lines forming the angle are perpendicular. Oh, okay, perfect. So line AB and line BC, are these two lines perpendicular? Well, by definition, perpendicular means it's two lines that form a right angle. So if they're forming a right angle, that must mean they're perpendicular. So for this answer is always. Let me just write it here, always, for this one. If two lines are parallel, then they're a coplanar. So in order for two lines to be parallel, by definition, they have to share the same plane. Like in the railroad tracks I was talking about, they have to be on the same earth or on the same ground, and they run next to each other. Okay? If they were on different things, like imagine a road and a bridge above the road, right? Those are skewed situations. So even though, and then if they were like diagonally to each other, so let me go back to the box here. So let's say BD and AE. So you could say those are clearly coplanar because it's on this plane, the front, this back side or the right side of the box. But let's say FG and BD. So FG is up here, BD is over here. So they don't look coplanar to you. But remember, you could make a plane any direction. So you can make a plane that goes diagonally across the side. So because you can make an angle that kind of like cuts the box in half like diagonally, and a plane that cuts it in half diagonally, that means they are actually coplanar. There is a plane that fits those both. So what's more important though is parallel is by definition coplanar. So because by definition, it's always true. Okay. If two lines are perpendicular to the same transversal, then the first two lines are parallel. Ooh, this is a good one. So if two lines are perpendicular to the same transversal, so two lines are perpendicular to the same transversal. So the transversal being line L here, and M and N are the two lines that are perpendicular. So this is 90 degrees, this is 90 degrees. Then the first two lines, so M and N, are parallel. Well, if you remember, we could tell if these are parallel or not parallel if they share the same angle. And since we said they're both perpendicular, that must mean they're both 90. And since they're both 90, that means they're the same angle. Because of the same angle, they are parallel. So this is always true. Okay? I think that I remember this is tripping people up because there was no nevers on this, and people assumed there was nevers on it, if I remember correctly, but I'm not sure. Okay. Oh, so this one. So we got to name the corresponding alternate interior, alternate exterior, and consecutive interior. Vertical, linear, or neither, or none. None of the above, I should say. Okay. So AD, so I'm just going to circle this, A and D. Well, they're on the same cross section, and they're diagonal to each other, so that's a vertical angle right there. BG, so B and G. So the transversal is M in this case, and my camera froze. The same transversal is the M in my case, and because of that, B and G is on the same transversal as M, so these two are corresponding. Or not corresponding, I'm sorry, because there's one on the right and one's on the left. This is alternate exterior, so alternate exterior. Angle H and angle S. So angle H is here, angle S is aquí. So over here, transversal, they're on the inside of the two lines, and they're opposite, so that's alternate interior. Because they're on the same transversal, which is this sideways line O, and then they're between the two lines that hit the transversal. J and K. So what is angle J and what is angle K? Angle J is here. Angle K is, where are you, angle K? Oh, it's right next to it. So angle J is up here, angle K is up here. So because they're both there on the same line and they're making a straight line, that is a linear pair. Last one, JT. So this is J and this is T. J and T. So this, they're not corresponding because corresponding is the same position. So this is top left, this is top left. They're not alternate interior because this is on the exterior. And they're not alternate exterior because this is the interior. And they're not vertical or linear because they're not sharing the same cross section. So because of that, these are neither or none. So this is a none situation. Okay. All right, so if P is parallel to O, so we're referring back to this thing over here, figure this out. So B is 49 degrees, what's G? So if B's here, G's here, these would be alternate exterior is congruent, so that is also 49 degrees. Let's go up here. Again, this is the image, so this I gave you out these blank tests, so I'm going to just refer to it off camera now. I'll just mention what they are. So C and F, so C is here and F is here. They're alternate interior. They happen to also equal each other, so that's 88 degrees also. If E is 53 degrees and D is 3x minus 2, then X, which is also alternate interior, is 53 equals 3x minus 2, plus 2 on both sides, 55 equals 3x. Divided by 3 on both sides. This is a fraction, but E and D, let me just check for sure. Yeah, they're alternate interior, so they have to be equal to each other. So that's 55 over 3. Oh, I think I remember people getting fractions on this, which is, should be 17, 18 and 1/3, or 18.3 repeating. Let's keep going. R and T. So R and T, I'm looking at it. R and T are consecutive interior. So consecutive interior means they add up to 180. So 4x plus 5 plus 6x plus 15 equals 180. So let's combine like terms. 10x plus 20 equals 180. So subtract 20 on both sides. 10x equals 160. Divided by 10, x equals 16. Okay, D and J, I'm looking at D and J. D and J are alternate interior. D and J are alternate interior. I made a mistake. I have to tell you that M and N is also parallel. That's my fault. But anyway, D and J is alternate interior, so we're going to assume they're parallel. So alternate interior means they're equal to each other. 7x plus 3. Subtract 6x plus 3, that would be 10 equals x. So that's 10. Right, notice I'm not spending too much time on the algebra itself, I'm just talking about the relationships. So we're going on to the next page. Okay, next page. Hey, I know these are parallel, so that means these are alternate interior, which means they add up to 180. So 130 plus 2x minus 70 equals 180. 30 plus minus 70 is 60 plus 2x equals 180. Divided by minus 60, 2x equals 120. Divided by 2x equals 60. Now let's just plug that in to check. 60 plus 2 is times 2 is 120. 120 minus 7 is 50. So 50 plus 130 is 180. That makes sense. Oh, well, looky here. So since they're both cross sections are parallel, or both transversals parallel, I know 46 equals 2x. So 46 equals 2x. And I'll just do it quickly. Why not? So x equals 23. So if x equals 23, that means this whole thing is 46. 46, and this should also be 46. So y equals 46. Make these questions too easy sometimes. Let's go to the next one. Alternate interior, 55 equals x plus 31. 55 equals x plus 31. Subtract 31 on both sides. X equals 24. Yep. Next one. If given that they're perpendicular, so given that they're perpendicular, that symbol, this symbol right here, means they're perpendicular, find x. So if they're perpendicular, that forms a right angle. Since it forms a right angle, 75 plus x plus 8 equals 90. So plus that, it'll be 83 plus x. So x equals 7, equals 90. Okay, so x equals 7. Over here, we have 3x minus 6 plus x equals 90. That is 4, I'm sorry, not 2, but 4x. And now minus 6 simplifies equals 96. 1 short of 100, so that's x equals 24. Okay. Again, I'm not spending too much time on the algebra itself. I think you guys got that. I care about the proofs and understanding the topics. Oh, okay. So write out alternate interior theorem proof, given that you can't use alternate interior theorem as a reason. So while alternate interior theorem is a theorem, one thing you can use is corresponding. Corresponding is a postulate. So corresponding angles are postulates. So this had a lot of options, okay? So P parallel to Q, always start with your given, that's always safe. Okay, so I want 4 equals 5, so I'm looking for this one equals that one. Well, let's see. I can start off that angle 1 is congruent to angle 4, and I know that because of vertical angles. I also know that angle 1 should equal angle 5, so angle 1 is congruent to angle 5, and I know that because corresponding angles. So corresponding was the glue that connects these two. Because 1 equals 4 and 1 equals 5, I could set them, use this as the bus to connect them, and use a transversal, which is, or not transversal, transitive property. Angle 4 is congruent to angle 5. And because 1 was the bus that connected these two guys, that is a transitive property. Okay? So that's the proof for the alternate interior. Did I put more of that? No, that's it for the test. Okay. That's good. Okay, let's go to test 4. Right angles have 2 acute triangles. Again, always some times number, my favorite. Right triangles have 2 acute angles. So a right triangle, this has to be 90. So these two have to add up to 90. So it can't be 90-90 because this is what it would look like if it was 90-90. From what we know from transversal, these would be parallel. So they can never meet up to become a triangle. So the two angles that form the other two angles, like if this is 90 degrees and the other two have to add up to 90, which means they have to be a little less than 90. So are the other two angles acute? Yes, always. So that's true. Or always, I should say. Also remember, by definition, a right triangle only has one right angle and two acute angles. And a obtuse triangle only has one obtuse angle and two acute angles. Okay, so I remember the wording was weird in this one, or a lot of people got confused on the wording. If two triangles have all three angles congruent to a corresponding angle, then the two triangles are congruent. So if two triangles, so these two triangles, and all their angles match with all these angles, 1, 2, 3, and I'll make this 3, and I'll make this 2. So if the pair of angles between the three triangles, or the two triangles, all match between each other, then the two angles are congruent. Now this would be called an angle-angle theorem if that worked for congruency. That works for similarity, which is later, but that does not work for congruency. So are they congruent? Sometimes, because you can have an equilateral triangle, which are all 60 degrees, be 6, 6, 6. And then you can have a bigger equilateral triangle with all the angles being 60 degrees, 10, 10, 10. So sometimes they could be the same, but sometimes they won't be, and that's okay. So sometimes yes, sometimes no. An isosceles triangle is also a right triangle. Well, isosceles triangle, the definition of isosceles triangle is that, let me get a better one, is that these two angles or these two sides are equal and their base angles, the base sum angle thumb theorem is equal. So does that necessarily mean this is a right angle? No. So my real question is, can it be a right angle? Well, you should know this from later that we do have a special triangle that we use, which is the 45, 45, 90 angle. And since these two angles are equal, that means these two sides are equal. So sometimes, and particularly the only time it happens, is the 45, 45, 90, but still sometimes. Let's call this the next one. Obtuse triangle is equilateral. Could that ever happen? Well, equilateral means they're equiangular, and equiangular triangles are 60, 60, 60. 60 is not an obtuse angle, so it's impossible. So this is never. The reason it's never, by definition, an equilateral triangle has 60 degrees as all three angles. By definition, an equilateral triangle, I should say, has 60 degrees. And because of that, because of that fact, it doesn't allow you to make it be obtuse. So this is a never situation. If a triangle is equilateral, then it's equiangular. I just mentioned this over here. So a triangle is equilateral. Does that make the angles equal? If you remember from the similar angle theorems, that these angles have to match if the sides are different or the same. So that is always true. That's just by definition. Always. I must have spelled always like 6 different ways throughout this video. Okay, so see, I hope you guys don't get too scared about the always, sometimes, never. Basically, is a definition question. Is it true? Is this by definition? Always equal to each other or not? Describe a triangle by the sides and the angles. So by angle, I could say it's obtuse, because you have one obtuse triangle. And this is a 10, 10, 18. So because it's 10, 10, 18, that is a isosceles. So it's both obtuse and isosceles. Okay, over here, write a congruous statement for the two triangles. So when we write a congruous statement, it has to all match. So from A to B, that's the one tick mark one. So A to B. And then B to C is the middle line, C. And then from D, oopsies, from D. Let me fix that. Then fix the camera too. So A, B, D, because from A to B is the single term, should be congruent to, so from A to B, so from A to that corner B, it should be C to that corner D, and some D to the diagonal B, and then B is the 2 tick mark to C, and D is the 2 tick mark to A, so that makes sense. So they have to match in some way. Completely so. That makes a good congruent statement. All right, given that this statement, find A and B. I feel like I remember this. People assume that one was equal to the other, but angle Y is going to equal angle O. So 38 is going to equal 2A minus 4. Oh, that's not a 2, that's a 7. A 7A minus 4. Plus 4, this is 42. 42 divided by 7 is 6. So A equals 6. And then the other setup, M goes with W. So notice here, though, W is not an equation. We need X. So how are we going to find X? Well, I know W is 74 degrees. And I know 38 is, 38 degrees. I should say Y is 38 degrees. So because of that, what we're going to do is set this all equal to 180. So 74 degrees plus 38 degrees plus 4b plus 8 equals 180. Let me combine all the non-variable terms. So 4b equals 74 plus 38 plus 8. I'm a little tired, so I'm just going to type it in the calculator. I don't want to make a mistake. 74 plus 38 plus 8 equals 120. Man, I make these numbers too clean. Minus 120, minus 120. 4b equals 60, so b equals 15. Okay, that's pretty simple. Yep. Let's flip. So we have 2x 76 and 5x minus 2. Now, you could figure out what this one is and try to figure out from there and then like set them equal to each other in this really janky way. But you should know this is called the exterior angle theorem. Is that the exterior angle here is going to be equal to the top and the bottom here. So for example, 5x minus 2 is going to equal 2x plus 76. I'm going to do plus 2 minus 3x, so 3x equals 78. Divided by 3, x equals 26. Yeah, so that equals 26. Did it ask for 26? Oh my god, so they asked for the BCD and ABC. So if I stopped there, I would have got it wrong. So angle BCD, so angle BCD is 5x minus 2. So 5 times 26 minus 2. So that is 5 times 26 is 130, so 128 for angle BCD. That's BCD. And then angle ABC, ABC is this one, so that's 26 times 2. So that's 54. So 54 is ABC. It makes sense that I ask you to find the ones with the variables. Okay. Hello, this one, CBA equals HKI. We got to make sure the letters match. Hey, these are right angles, though, so that makes our life easier. So does C go with H? So C goes with H, that makes sense. So does B go with K? So B goes with K. So we don't know what B is. And we know A goes with I, so A goes with I. I know what I is at least. So I'm going to do 52 degrees. And my camera freezes every time. So I'm going to do 52 degrees equals 2x plus 18. Because these two angles are congruent. Congruent triangles have congruent angles. Subtract 18 on both sides, so you got 2x equals 52 minus 18 equals 34. Funny I have to use a calculator for that. Divided by 2 on both sides, x equals 17. Now, am I looking for x? Yeah, so I'm happy with that. But how am I going to find b? Or I'm going to find y, actually. Well, I know 52 degrees is this, and I know this is a right angle. Right angles are 90. So I could do the same setup as before. 52 plus 90 plus 3y plus 11 equals 180. So we're going to do 52 plus 90 plus 11 equals 153. So 3y equals 1 plus 153 equals 180 minus 180. 3y equals 27. Y equals 9. I realized I was off camera, so I'll give it a second to look at it. Again, you just set it up and add it up to 180. Please remember that all triangles add up to 180. All right, let's keep it going. Wow, this chapter is a long one. Oh, so these are fun. So we have to use the congruent statements, or how do we know? So we have a couple of situations. You have side, angle, side. You have angle, side, angle. You have side, side, side. And you have, there's one more, I'm pretty sure, hypotenuse length. And then you have one more after that, which is, angle, angle, side. What ones you cannot use? So this is no. So no, you cannot use these. Well, the one that spells a bad word, but I'll put it backwards, side, side, angle. Also the one that is, I don't know, auto assurance, AAA. So no angle, angle, angle. That can be used for similarity, not congruency. And side, side, angle does not tell us anything. Oh, camera froze again. So with that in mind, okay, look at this. So we have a side, you have a side is an angle. Well, side, side, angle is not okay. So this is not congruent. Okay, over here, this triangle is going to look familiar later. If this is a right angle, this means this is a hypotenuse. And since they share the same thing, that's a leg. So you can write hypotenuse leg. Okay, this one, this side should equal to that side. That's reflexive. So WY equals WY. 6 equals 6, 9 equals 9. That's a side, side, side. Oh, these are my favorite. So if you know these are vertical angles, so you have multiple choices. Actually, no, you only can say these are vertical angles for sure. So this is 90 and 90, so that's a congruent angle. And then the sides are between the two angles. So then it's angle, side, angle. You got to read it like it's on the triangle. Angle, side, angle. The other one, the angles were, like the other one was like side, side, angle. And that's not okay. Because the side is between the two angles, that is okay. So we're happy with that. All right, look at this one. Well, this one, you're like, oh, well, look at this. Side angle, angle. You're like, wow, that's perfect. And here, side angle, angle, which is perfect. So angle, side, side. But you can't use angle, side, side. Or sides, or I'm sorry. It is, I must be really tired now. Side, angle, angle. Because side, angle, angle, side, angle, angle. Okay. This one, since you know these are parallel, you should know by now, when you see parallel symbols, that gives you the big hint that you are about to enter the transversal zone. So because they're transversals, you can know that these are alternate interior. You also actually know that these are alternate interior based off that triangle, but you only need one of them, so I'm going to use one of them. So at this situation, you could say angle, side, angle, and that would be true. If I use this one instead, I would just write angle, angle, side, which is also true. So this one had multiple ways to solve, funny enough. I mean, a lot of people miss that. And remember, the transversals are a big hint that you can set them equal to each other. All right, find x, then find the length of the side or angle. Okay, so I asked you for part 15, 16, that's 17, 18. Man, I suck at typos. 17, 18. So, what can I do with this? Well, I know these two angles are the same. So if these two angles are the same, the opposite sides are the same. So 28 equals 9x minus 8. So I'm going to solve that. Plus 8 on both sides, that's 37. Wait, that can't be right. That's 36, and then 36 divided by 9 is going to be x equals 4. So I found x equals 4, and I'm going to plug it back here. 4 times 9 is, again, 36. Wait. Actually, I already know the length of this side, because if this is 28, this also has to be 28. So CB equals 28. That's really funny. I didn't even have to do the math for that. Oh, okay. So this one I do have to do the math for because these two sides are equal. That means these two inside angles, base angle theorem is equal. So we got 7x plus 5 equals x plus 24. 24. That must be real tired. 47. We're going to subtract x and we're going to subtract 5. 6x equals 42. Divided by x on both sides, x equals 7. So x equals 7. I could plug it into either one of these. They're equal to each other. 7 plus 47 is 54. So 54 degrees, I should say. Okay. Hey, another proof. Okay, let's zoom out a little bit. Let's zoom out a little bit. All right. Oh, so I filled this in for you. Well, very nice of me. So, given all this information, prove that this. So I just want to draw it out for myself. So I know that AB is parallel to DC, and I know AB is congruent to DC. Oh, that's very useful. Well, since I know they're congruent because they're given, and I know they're parallel because that's given. I know these two angles, BAC, so BAC, so this angle here, and this angle here, should be congruent because that is a transversal, and transversals, we know that alternate interior of two parallel lines of a transversal of two parallel lines. Alternate interior. And then AC equals AC, so AC equals AC. I know that because that's the reflexive property. Reflects on them. And then these two triangles are equal because this is equal, so side, angle, side. So side, angle, side. Okay. Oh, this one is fun. Okay. Two column proofs don't need to use all the rows. So given B, D, and given that point E is the midpoint. Oh, that's a lot of information actually. So angle B is congruent to angle D. We know that because that's given. Oh, I already drew on the test. Okay. Now, point E is mid of BD, line BD. So line BD is this line. So this is the middle, that's given. So because that's given, we know that DBE is congruent to ED. And we know these two are congruent to each other because midpoint, the definition of midpoint. Okay. Number 4. So we know that. Oh, I know this angle E and angle E. So angle, I have to be a little bit more particular because there's multiple angle E's. So angle DEC, so that's the bottom one, is congruent to angle AEC, angle AEB. That's the top one. I know that because of vertical angles. Definition of vertical angles. Oops, definition. Is it definition? I forget what it is. Vertical angle congruence. But let's just do vertical angles. If you wrote that in the midterm, I have to give you credit now. So we know that these angles are equal. We know that, I got to put it in a shot. Angle, side, angle, and I should say these two are equal to that too. So angle, side, angle. Hey, angle, side, angle. And I'm just going to copy what the proof says. So triangle ABE on this triangle ABE is congruent to triangle CDE. Okay, so triangle ABE is congruent to CDE because of angle, side, angle. Okay. Hey, this triangle should look familiar a couple problems back because this is literally another hypotenuse length, a leg. But whatever, let's check it out. This actually had multiple ways to do it. If I remember, Brianna showed us that you could use base angle theorem. I'm going to show it my way, which is the using the right angles. So we know LM is congruent to LJ. So LM is congruent to LJ. And we know that from the picture. And we know that because it literally says that. So that's given. So we know that angle. Why did I write angle? I could just use the angle symbol when I'm writing it. Angle LKM is a right angle. Because that's given. Hey, this was, and my camera froze. So this is a right triangle. Now what's very useful about right triangles is that all we need is the hypotenuse and the leg to prove it. So we have the hypotenuse are equal to each other. That was given. And we know these leg is given, or is equal, because Km is congruent to Km. And that's true because of reflexive property. Reflexive property. Property, P-R-O-P-E-R-T-Y. So then, given reflexive, hey, I got the leg, I got a hypotenuse, and I know it's a right triangle. Hey, so triangle LKM is congruent to triangle JKM, and those are congruent because hypotenuse line. There's other ways to do that triangle, but I felt like that's the most straightforward. Oh, we're almost caught up. I'm not going to do practice test 7 because I already did that in class, so I'm going to finish at chapter 6, okay? So, and only an hour 17 in. So questions 1 through 4, use the diagram to fill the blank. So there's a lot of things going on here, so let's make sure we know. AB is parallel to a couple of lines here. You could say YC, you could say CZ or Z for the British, or you could say YZ or Z. So I'll just say YC, YC. XY, so XY is this left one over here, should be parallel to CB. Okay. That's the only choice you have, actually. If AC is 3, so if AC is 3, then XZ, so this one over here, if this is 3, so if this is 3, this is 3, and this is 3. So that means that this has to be 6. And if YZ is 7, so YZ is 7, then AB has to be half of that, which is 3.5. Cool. All right. So this is a mid-segment theorem. So this is going to be half of that. So there's 2 ways I could do it. I could say that I need x plus 3 equals x plus 6. Because this one's smaller, I need to multiply this one by 2. So I'm going to multiply this by 2 to make sure they match. So distribute that 2. Hey, it looks like the half disappears perfectly. So x plus 6 equals x plus 6. I made a mistake somewhere. I remember I made a mistake earlier. This ends up being all reals. Minus 6, minus 6. So you got x equals x, which is not real. Or that's all real solutions. I think on the test, I changed it last minute because this causes an all real situation. But this is how you set it up. You times the smaller piece by 2 so they match. Okay, this one over here, AX is 2, XY is 3, BC is 9. Find a perimeter. Okay, perimeter just means all the outside added together. So BC is 9, so let me just write that. So BC is 9, so this big long line is 9, that's good. XY, so XY, this one is 3. If this one's 3, then this whole thing has to be 3 plus 3 or 6. And AX, so AX is 2. This one's also 2, so 2 plus 2 is 4. So 6 plus 4 plus 9 is 19. Remember, perimeters just add the outside. Around the outside. Oh, this one where I gave you fake information. I remember people sweating bullets for this. There's no need to worry about this. You should know what it is. So, for this one, we're going to do the value of, hello camera, we're going to do the value of x in the figure below. Oh, what the heck? I have a bunch of x's. So I need to figure out which ones are equal to each other. It's probably the ones that both have right angles and are going to the same thing. These are, this is angle bisectors, and the points that go to the sides are going to be all equal shape. So that means 2x minus 1 equals x plus 5 plus 1 minus x equals 6. It's a lot easier than you thought. You just have to have confidence. Oh, this one. From the information on the line, hey, this triangle looks familiar. From this information from the given, is line BD a perpendicular bisector, median, an angle bisector, median segment, altitude, or none of the above? So that's really interesting. So for this one, we have to figure it out. So is it a perpendicular bisector? Well, I know these two angles are equal, so that means this has to be equal, so that means this has to be equal to each other, I should say. Because this is going to be an isosceles triangle, and we know these two triangles are congruent. I believe this might be the makeup version. I don't remember. Or this is the original version. But I made another triangle for the makeup tests, which was a little different. So this one's pretty funny because you could figure out that these two are equal to each other, it tells you a lot of things. First, is it a perpendicular bisector? It means it has to be perpendicular and it bisects a line. It does that. So PB is good. Now, is it a median? A median has to go from the corner to the middle of the other line. And since these are cut in half, you know it's a median. Angle bisector, it means you have to cut this angle in half. Well, we know these two angles have to be congruent because this is a congruent triangles. So it's also an angle bisector. A mid-segment, so a mid-segment means it has to go from the middle of one line to the middle of the other. Doesn't do that, so not mid-segment. Altitude means it has to be a right angle and goes to the corner. It does do that. So that is a altitude. Or none and above. We clearly saw there's more than one and above. So those are the applies. The perpendicular bisector, the median, the angle bisector, and the altitude. Let's keep going. Oh, hey, this looks familiar. In this diagram, the perpendicular bisector triangle meet at point D. So that point, I forgot what was the point called, point of concurrency, but so find the length of BD. So if BD is this one, it probably matches this one over here. So that's 13.5. Find the length of AG. So AG is this line here, which matches this line here, which is 7. All right, perfect. Let's keep going. Hey, this is the grind road. The in-center. So the in-center, I believe, is the... what is the in-center again? Oh, the in-center is the intersection of all the angle bisectors. So that means this angle is matched to this matched to this, and this should match to this. All right, what's the measure of GBD? So GBD. If this is 20 degrees, this is also have to be 20 degrees. What's the measurement of GD? So if GD is this one, which is the right angle one, it probably matches this right angle one here, which is 4. Again, very simple, but you just need to know the relationships. Mathematically, very simple. You just got to know the relationships. Hey, hello there. In the diagram before, V is the centroid. So the centroid is the intersection of all the medians, I believe. So that means this sides are equal, this sides are equal, and these sides are equal. 3, 3. Okay. So SU. So SU. Oh, and it also means this is 2/3. So SU, if this one from the corner to the centroid is 6, so that's the 2/3 one, this has to be half of that, which is 3. And then 6 plus 3 is 9. What's the measurement? UV. So UV is this one, which I already pointed out already, which is 3. Oh, we use this one too. So if RV equals, so RV, which is this line here, equals 10x minus 4, equals, and we know Vx is 3x plus 6, how do we set these equal to each other? So this, I remember, was a tough time for you guys. If this is 2/3 and this is 1/3, that means this is going to be half the size as that. So in order to make Vx match the size of RV, I would multiply this one by 2 in order so they could match. So I have 10x minus 4 equals 6x plus 12. Minus 6x plus 4, that's going to be 4x equals 16, x equals 4. So the key problem here is figure out what you have to multiply. In triangle ABC, angle A is 40, angle C is 60. What's the longest side of the triangle? Oh, so we got to draw our triangle. A, B, C. Excuse me. Excuse me. Okay. So angle ABC. If I know this is 40 degrees and this has to be 60 degrees, they have always add up to 180. So that's 80 degrees here. So which is the longest side? It's the side across from the 80 degrees, which is line AC. So line AC. Okay, next one. I just held back a sneeze. If triangle KLM, K, L, M, and KL is 9, and LM is 12, and MK is 13, the largest angle is going to be across the biggest side, which is angle K. No, which is angle, oh, I must be real tired. I made a mistake. So this is 12, then this is 13. MK is 13. This is the K. It should be a K at least. So it should be across the largest side, which is actually this one. So this is angle L. Okay, that is angle L. You also could tell because if this makes the line MK, if that makes the line itself, that must mean that it can't include the angle L because K is at the one end and M is at the other, so it must be angle L. That's how I figured it out quickly. I made a mistake, but just to help you understand it in a different way. Well, I think I removed this question in the last minute, but it's so interesting. So if you had a triangle that is 43 degrees, so a triangle, let's draw the triangle. This is 43 degrees and this is 64 degrees. So 64 plus 43 is 107, and then 107 minus 180 is 80, is a 73, so 73 degrees. Would the altitude be drawn on the inside or the outside? Or on the triangle. So this is a acute triangle, so the altitude would be on the inside. If you check your old test, I don't believe I put this question on. I think I removed it at the last minute and changed it with something else. So if you're using your old test to compare, it might not match. There's going to be a mismatch. I'm pretty sure of it. And I apologize for that. This must be an earlier draft of my test. And my own guy is not viewing. Okay. So, oh, this one's baby. So this is CAD, so this angle, in measurement compared to angle D. So how do I know which one's bigger? Well, this one is across of the 8, and this one's across of the 12. So since this is across of the 12, I know CAD is bigger than the 8. Okay? AD and AB. So AD, line AD, so this line, and line AB, which is this line. This is 110 degrees, and this is 90 degrees. So typically you can't tell when they're two separate triangles, but because of something we call hinge theorem, that we know the two sides are equal to each other, so this is 8 and 8, and this is 12 and 12, we know that you could compare these two sides the same with the angle. So if this is 110 and this is 90, BD is bigger, or AB is bigger, so AB. Let's keep going. Measurement angle B and measurement angle BAC. So B over here, an angle, what? BAC. Oh, and this angle here. Again, same situation. If this is 8 and this is 12, the one across the 12 is going to be bigger, so it's angle BAC wins again. Okay. Wow, we got so much to do. Oh, these are easy peasy. So is it possible to draw a triangle? So this is how you tell. You take your two smallest ones, 12 plus 13, 12 plus 3, and it has to be bigger than 15 in order to be possible. This is 15 is equal to 15. Because they're exactly equal, that's a no. 40 plus 8 is 48. 48 is bigger than 41, so that's a yes. 12 plus 1 is 13. 13 is smaller than 14, so that's a no. Two sides of the triangle is 11 is 6. So I feel like I remember talking about somebody. Your range is going to be what is subtracted by and what is added by, because that's the biggest possible side and the smallest possible side. Why did I write 8? It's a 6. So 11 minus 6 is 5, and 11 minus 11 plus 6 is 17. So your range is from 17 to 5. Another way you can write it is 17 is, or I should write 5 is less than x, which is less than 17. Both are good. Probably would write it like this if I put it in a multiple choice test. Not that you have one coming up or anything. Oh, chapter 6 on the home stress. What is it now? Almost 8 o'clock. 1 hour 30 in. Okay, a little shorter than the other one, which is good. So long, I don't know why. Describe the polygons are similar. If so, write the similar statement. So similar means they have to be proportional. So let's check if this is proportional. Is 6 to 9 equal to... So, and how do you know which size goes with which? This is really important. Small goes with small, the medium goes with the medium, and the big goes with the big. So, 9 goes with 6. Let's see, 15 or 12 is the medium on here, and 8 is the medium here, so that's 8 to 12. And 10 and 15, 10 to 15. Funny enough, you actually already know because angle, but let's ignore that for now. So this is going to reduce to 2/3, and this reduces to 2/3, and this reduces to 2/3. Because all the proportions are equal to each other, you know they're similar, so yes. Let's go here. So small goes with small, so 4 and 6, and 4 and 6 is the same thing, and 8 to 10. Now for this one, you knew angle because they're triangles. Because these angles match doesn't necessarily mean they're similar. So 4/6 reduces to 2/3, while 8/10 reduces to 4/5. That is not equal to each other, so that is not similar. Oh, and I was supposed to write a similar statement for this. So AXR is similar, I should use the curly lines, I think it is similar to NMT. Okay, so this one. In the diagram, polygon ABC is congruent to, or similar to polygon GHIG. Answer each question based on this. I didn't even flip it. What's the scale factor? So the scale factor, you could do 5.5 to 11. So the smaller, this one is 11 to 5.5, which you could reduce to 2 to 1. So I could write 2 over 1, or I could have wrote 2:1. Now the reverse, this is going to be reverse, which is going to be 1 to 2, or I should have just wrote it here, or 1 over 2. Or I guess I could actually say 1 to 2. It's a ratio, so you can technically write it all 3 ways. All right, find the values of x and y. So we know this is going to be double the size, so 8, that's going to be 16. And this is going to be half the size, so this is going to be 8 to y, which is, so 16 equals x, and then y should be 4 equals y. Very simple. That question was way too easy. I'm going to keep that in mind. Let's keep going. Almost there. How much pages? A couple of pages. Oh, what is this? 6 to 8 decided is similar based on the information. So I made you draw this triangle for some reason. So A, B, C, X, Y, Z. I like when Z's match with C. AB is 10, and BC is 15, and XY is 2, and YZ is 3, and angle B is congruent to angle Y. So first we got to see if these sides are proportional. So is 10 the same proportion to 2 as 15 is the same as proportion to 3? Actually, wait, do we care about that? I got to make sure. B, C, X, Y. Wait, Y, Z, yeah. Do we care about that? Oh, yeah, that's still proportional, actually. So that's 5 over 1 equals 5 over 1. Yeah, you do care about that. I'm sorry. So these are proportional, and you know the angle inside is equal. So this is a side angle side situation. Oh, let me list all the possible ones for similar. So this is similar. So you have angle, angle. I believe you have, again, side angle side. And you should also have side, side, side. Angle, side, angle. No, because as soon as you know two angles are equal, you don't need to know angle, side, angle. You just know two angles are equal. So I think this is it in terms of what we could use. Maybe I figure out the other one. I don't remember right now. Okay, so 28, 72. I know this tripped up some people from 100. So 72 degrees and 28 degrees. Well, 72 degrees, so this one will have to be 72 plus 90 minus 180 is 18 degrees. And this one would be 62 degrees. So because of that, these angles are not similar. Are congruent, so they're not similar. So this is a no, not similar. Over here, hello, parallel lines. Parallel lines is a big hello to this is going to be congruent angles because they're, what do we call those things? Transversals. And these are, in this case, corresponding. Angle, angle, that's enough for me. You also know that this angle is going to be reflexive, so you could just get angle, angle. I could have made a proof for this one, I just realized. Okay, maybe I did, I don't remember. So this one, let's see, small goes with small. So 3 goes to 6, the same way 4 should go with 8. And we have the angle in between matches, and the proportion is 1 to 2, which is equals 1 to 2, that's good. And the angle matches, so that's side, angle, side. We're happy with that, good. Here we have 6 to 12. Now, how do we know if CD is congruent to DE? There was like no wrong answer to this except none. So because you know these are mid segments, you know that these two lines are parallel. So you could have said that these are angles and this is angle. So you could have said angle, side, angle or something like that. You also know if this is 6 to 12, so the scale factor of 6 to 12 is 1 to 2. You know this angle is going to be like, let's say if this is 5, this has to also be 5. So this will always be double. The same way here, 5, or let's say 6, and this will have to be doubled, which is 6. So, but added together is 12, so the big triangle is 12. So all the possible answers here are side to side, 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 angle, angle. There's so many, like the only wrong answer will say no, it's neither, or not similar. So that's a funny question right there. Okay, solve the proportion for the missing variable. So proportions are pretty easy. You just cross multiply. So A goes to 3 the same way 6 goes with 4. You could also write it as A goes to 6 equals 3 goes to 4, because you could say this side with this side goes with this side with that side. Or you could say this part of the triangle goes with this part of the triangle. There's the same thing. You're going to get the same answer, notice. So you're still cross multiplying the same thing. So 4a equals 6 times 3 is 18. Oh, there's a fraction. That's interesting. A equals 18 over 4. Which I could reduce to 9 over 2 or 4.5. Yeah, that's funny. Yeah, that's it. Okay. This one, so the proportion between two transversals, if you all know all these things are parallel, you know these pieces are going to be proportional. So 8 goes with 10, the same way 6 goes with x. There's multiple ways to set a proportion. You could have said x goes with 6, the same way 10 goes with 8. You could have said x goes with 10, the same way 6 goes with 8. You'll still get the same answer. So you get 8x equals 60. That's strange. Did I really make them fractions? I don't remember this. That's strange. X goes to 6. Yeah, that's correct, though. This one, X goes to 10. 6 goes with 8. That's still the same thing, yeah. Yeah, I just made it fractions for some reason. That's very interesting. So X equals 60 divided by 8. My brain is a little fried right now, so I can't think. 7.5. Oh, we're almost there. 2 more sheets. that dreaded last page that people complain about, but people did pretty well. Let's set this up. 4 to A equals, if 4 I use 4, I got to use 12 to 18. So 18 times 12, gosh, I can't even think. This should work. 18 times 4 equals 72 equals 12A divided by 2 is 6 equals A. Okay. Right angles here. What is this? Oh, we know for a fact they're similar. I guess I'm telling you they're similar. Do I have enough information? Oh, angle. Yeah, you do have enough information. So, since this is across from this, you know that you have to set up the way. So 5 goes with 25. The same way, x plus 2 goes with 15. Cross multiply, 15 times 5 is 75 equals 25x plus 20 plus 50, because I've distributed the 25 to both of these. Minus 50 is 25 equals 25x. Easy work, x equals 1. Here, 4 goes to 4n plus 1 equals 5 goes with 7n minus 1. So I'm going to multiply it out. I'll just draw it out first because I realize I'm going a little too fast right now. Just trying to finish up. 7n minus 1. And that equals 5 times, and I was going to distribute the 4 early, so 4n plus 4. So distribute. You're going to get 28n minus 4 equals 20n minus plus 20. So you got to get 8n, I subtract 20n from both sides, and plus 4 on both sides, equals 24. N equals 3. I feel like I remember this answer exactly. Yeah, n equals 3. Remember from here, just divide 8 on both sides. So 8 to both sides. Okay, so people dreaded this one, but it wasn't even that bad. Yeah, you had to deal with decimals, but let's just fill in everything, and then we'll just answer the questions. So let's see what we got. So 4 to 3 is the same as 10. Actually, I guess I will solve one at a time. Let's just do that. So what's AG? So AG is this guy right here. So we'll call this X. So because these are parallel lines, I know the ratio. So I could do 6 is to 4 the same way as 4 is to X, which is going to be the same as 4 times 4 is 16 equals 6X. And divide that stuff is going to be 16 over 6, which reduces to 2 and 2/3. So 2 and 2/3, 16 over 6. I think 2.6 repeating. They're both all good answers. So 2 and 2/3. Okay, now find FC. So FC is this line here. So I could do 4 to 3. So this side 4 goes with this side 3. The same way this whole side, so you got to make sure you include the whole side, which is 10, goes with the whole side here, which is X. So you get 30 equals 4x divided by 4 divided by 4. 30 divided by 4 can simplify to 5, 6, 7, 7.5. Is that right? Yeah, 7.5 equals x. 7.5. I remember it was 30 over 4. Was it 30 over 4? I don't know. We'll keep going and we'll see later. So ED. So ED is this one. So I call this one, let's not call it X, let's call it Y. So ED is this longer one. So we can still use the same proportion. 4 to 3 is going to be equal to this whole side, which is 4 plus 6 plus 5, which is 15, over this side, which is Y. So we get 4y equals 45 divided by 4 divided by 4. Y equals 45 over 4, which if I were to simplify is 11 and 1/4. So it's 11 and 1/4. And this is 7.5, so this is kind of looking, makes sense. Yeah, that looks kind of right. All right, find AE. So AE is this whole line over here. This whole line over here. So to find the whole line, it's not too bad. Because I could establish that these are all similar triangles, I could just have this line. Uh, mm, hmm. Let's see. Let's see. What could I do? I can find FE, I guess, and then add them all together. So let's do that. Let's find FE. So we'll call this Z. So we know 6 to 4. So 6 to 4 should equal 5 to Z. So that is 6Z. Is that on camera? Good. Equals 20. Divided by 6, divided by 6. Z equals 20 divided by 6 is going to be 1, 2, 3, 3 and 2/3, 3 and 1/3. 3 and 1/3. Yep. So that's Z. But that's not my final answer because I need to find the whole line. So this is 3 and 1/3. So 2 and 2/3 plus 4 plus 3 and 1/3 is going to be, this is going to be end up being 6. 6 plus 4 is 10. 10? 10? Is that true? 10. Is it really 10? Did I mess this up? No, that's definitely 18, so that's 2 and 2/3 and 1/3. 2, 6, which is 1/3. This one is 12 and 4, 6, so that's 2/3. Why am I doubting myself? Let me keep going on this. Make sure I get it right. Well, let me keep going on this, make sure I do it right. So let's do it another way, just to make sure, to check our work. Because 10 feels too easy, or 10 feels too clean. I don't remember it being that clean. So let's try, let's see. Let's do this whole side with the small side. So we're going to do 4 plus 5, that's 15 over 4 equals 15 over 4. So 15 over 4, which should equal this whole thing, which I assume I don't know, which is x over this, which I found over is 2 and 2/3. Let me leave it as a fraction because it's easier to work with a fraction. So 2 2/3, which is 16 over 6. Or I could reduce that to divided by 2, 8 over 3. Okay, so we're going to times this. So 15 over 1 times 8 over 3. I could cross that out. 1, I could cross that out. It is 5. 5 times 4 is 5 times 8 is 40 equals 4x. Hey, look at that. I was actually right. Divided by 4, divided by 4. X equals 10. X did equal 10. So this is 10. And it didn't record what I just said, so I'm really mad about that, but I'll point it out one more time. So I set this up 15 to 4 because I could do the long side to the short side. So that's 15 over 4 equals x, which I call, let's call this big thing x, to the short side, so that's the long side to the short side. So that's 2 and 2/3, which I found earlier. And I'm confident enough to reuse again. Now, 2 and 2/3 can simplify to, or could be redrawn to 8 and over 3. Because it can be redrawn to 8 over 3, I can just multiply it a little better. And then I do 15 over 1 times 8 over 3. I can cross simplify. It makes this 1 and it makes this 5. So 5 times 8 is 40, which is here. 40 equals 4x divided by 4 on both sides. X equals 10. I just wrote it 3 times. That really implies that x was equal 10. So that big side should be 10. So I'm happy I did it in 2 ways to check my work. Maybe that's why you guys thought it was rule. It's crazy because all at the end it was a clean number. All right, that's my test packet right there. I just did it all in less than 2 hours. I hope you guys use this video to help you. I do this because I want to make sure you succeed, and I want to be the reason why you guys succeed. But honestly, it's not me ever. All the glory goes to you guys. You guys are all intelligent. You guys are all wonderful. I'm very proud to have you as my students. And what I really, really care about is that you guys do well in this midterm. And I want you to do that without having to stress everything out of your body and panic. So this video is to help supplement that. The videos help to go on your own pace and check out and be able to have questions maybe answered when I can't answer the questions directly. Again, you could ask questions on chapter number 7 because I did that fake chapter 7 test. So, and we went over that in class. Otherwise, it's a little past 8 for me. I'm gonna go home and then go to sleep. I hope you guys have a wonderful night. Again, do that typical YouTube stuff, like, subscribe, comment on my video for a giveaway. Just joking. Otherwise, have a wonderful night. Good luck on your tests, guys. I know you can do well on it. I'm very proud of you guys. Thank you for watching.